Have you ever wondered how to automate data extraction, transformation, and visualization in fully scalable cloud environment? What if you could collect real-time YouTube data, process it with Apache Spark, store in Snowflake, and create standing dashboard all with minimal effort? Welcome to this deep dive into building an end-to-end ETL pipeline. I will explain everything step by step in simple manner, from understanding data extraction, understanding the ETL, understanding structure of Docker, and we'll also discuss some of the prerequisites required for this project. So many cool things to do in this project. And if you are seeing this channel for the first time, then my name is Tarikul Ismail. I am a freelancer data engineer. On this channel, I mainly talk about data engineering, freelancing, and productivity. So if you like this type of content, then make sure you hit the subscribe button. And if you learn something new from this video, then make sure you hit the like button. Let's dive in and see the pipeline in action. One of the tasks you will do as a data engineer is to build a data pipeline. Basically, you take data from multiple sources, do some transformation in between, and then load your data into some target location. Now you can perform this entire operation using simple Python script. All you have to do is read data from some APIs, write your logic in between, and then store your data onto some target location. There is something called as a ETL job. So if you want to run your script at a specific interval, you can schedule it using ETL job. It looks something like that, but there is the thing, you can use ETL job for, let's say, two or three script. But what if we have hundred of data pipelines? We know that the 90% of the world's data was generated in just last 2 years, and business around the world using this data to improve their product and services. The reason you see the correct recommendation on your YouTube page or the correct ads on your Instagram profile is because of all of this data processing. There are more than thousands of data pipeline running in the organizations to make all of these things happen. In this video, I will walk you through the creating an automated ETL extract, transformation, and load pipeline using Apache Airflow and PySpark. This pipeline will fetch trending videos data from YouTube data API, process it, and then store the processed data in AWS S3 deployed in Dockerized environment. After that, the data analysis in Snowflake and create dashboard in Google Looker Studio. I'm beginning the practical implementation of the project. First of all, we need to obtain a YouTube Data API key. Visit the Google Development Console, create a new project, search the YouTube API and enable it, generate new credential, and copy the API key for the later use in the project. Next, we need to acquire AWS Access Key ID and secret access key. Log in your AWS Management Console, navigate the IAM Identity and Access Management section and create a new user. Attach the necessary policies for S3 access and create access key. Save the generate access key ID and secret access key security for use in this project. Start my Python coding in Visual Studio Code environment. Here I have created a Airflow project. Under this project there is a folder Airflow and another two files, there's a Docker file and Docker composite.yml file. Docker file included all the necessary package to run the project, and another one file is docker compose.yml file. In this file contains AWS access key ID, AWS secret key ID, and E2 API key. For the security purpose, I didn't share my key. I will use the key in this file which I got earlier from Google API console and AWS IAM Center. Using a Docker Compose YML file is beneficial for handling multi-conditional Docker application. It enables to define and run several Docker containers with single command and allow us to configure environment variables, volumes, ports, and other settings for each services in a clear and organized way. With Docker Compose, we can start, stop, and manage multiple services effortlessly using a single command, docker compose up. This is docker compose up or docker compose down. And another one I have missed previously, the docker file, which need to build the image. And inside the Airflow folder there is a YouTube ETL dag.py. A DAG, directed acyclic graph in Apache Airflow, is a workflow that defines a sequence of tasks and their dependencies. It is the backbone of any data pipeline in Airflow. All the above libraries are required in implementing this project. They will all become useful once we start building the code. You will see errors in VS Code because all dependencies are installed on Docker but not on local machine, so don't focus on them. If there are any syntax error, Airflow shows it on the top of screen, and for logical errors exception we can see them in Airflow logs. We are defining a DAG named YouTube ETL DAG that runs daily midnight 12 am. I have defined the time, and this DAG will be managed and triggered by Airflow, so there is no need to run anything in VS Code. Simply update the Python file and Airflow file automatically detect and incorporate the changes. We are creating task named extract task, and this is the extract data. We are defining callable function extract data, which is invoked in extract task. We will use PySpark for this task, a powerful framework designed for handling large dataset and performing transformation. Although we could use pandas, since our dataset isn't particularly large, I prefer using PySpark. I have been learning PySpark recently and I find that practical implementation is much more engaging than just studying the theory. It creates a task named pre-processed data PySpark task, and this task calls the pre-processed data PySpark job function. The pre-processed data PySpark job function cleans the data. The clean data is stored in folder named transfer YouTube data current date. Within this folder, a new CSV file named with the prefix part dash will be created, which has the clean data. We created our final task, load data to S3 task, which invokes the load data to S3 function to upload our file to the S3 bucket. You can verify the upload by checking the contents of the S3 bucket. The final code is extract task, the sequence, pre-process data type task, and load data to S3 task. This all. Open the Docker desktop app from my local machine, which I've installed before. Start the project. After open the Docker desktop app, I have seen that image already created in this Docker from the VS Code, the compose of the docker compose.yml file. Here is port 8080, which I have already mentioned in docker compose.yml file. Right now I am going to click the port to launch the Airflow DAG. Here is the Airflow DAG, which I creating in VS Code YouTube underscore ETL underscore DAG file. This is my DAG. in this graph. The task sequence is shown here. Also, the VS Code updated in the DAG. All code has updated accordingly. Now I'm going to trigger the DAG. The extract task is queued and running. Right now, the task has successfully completed. Now I'm going to check my AWS S3 bucket. Here is the AWS YT bucket, YouTube bucket. In this bucket, there is a process data. Year 2025, month of February, and today's date 27th February. Yes, the file is generated right now. I'm going to open the CSV file, download it. No. Yes. Right now I can see the YouTube file, API file, the video ID, title, publish date, as well as view count, like count, comment count, channel count. So the DAG process has completely run and create the file in the bucket. So that's all right now. I have already shown the how to extract data from YouTube API and store it in AWS S3 bucket. I have already shown the CSV file. Right now I need to analyze the CSV files data, which I can do it in any local SQL database or MySQL database or SQL Server or PL/SQL database. But now I want to use a new technology, a cloud-based data warehouse. So Snowflake came into the picture. Snowflake is a cloud-based data warehouse that provides scalable, high performance and fully managed storage, computing and analysis. Unlike the traditional on-premise database, Snowflake is built natively for the cloud and offers automatic scaling, pay-as-you-go pricing, and seamless integration with modern data tools. I also want to show my hands-on experience, a little bit potential experience in Snowflake. So that first we need to create stage for the access the S3 bucket. Here is the URL of S3 bucket, credentials, the AWS key and AWS secret key, or which I have collected in the beginning of the this project. Um, with this key and access key, I have created the stage. Uh, from this stage, we can access the S3, the CSV file, and from this file, the required column included in this external table. We have to create the external table from this CSV file. I have already created the external table. The external table name is extytcsv, and from this external table I have created the view to some logic. Also have created this view, and right now from this view I can access the data. I will run the query. Yes, and the query is showing the data from S3 bucket. Also count the data. Yes, the data quantity count is 2444 data. That is the all of Snowflake. Now I am in almost end of this project. It's time to show the data visualized in Google Looker Studio. For visualization the data from Snowflake DB, uh, I have chosen the BI tools is Google Looker Studio, because Google Looker Studio, formerly Google Data Studio, is a free business intelligence BI tools that allows you to create interactive reports and dashboards. It integrates seamlessly with various data sources, including Google Analytics, Google Ads, BigQuery, SQL database, and third-party connection like Supermetrics. It's 100% free to use with no need for expensive license. Being cloud-based, it allows access from anywhere with in internet connection. Over 800 plus data connectivity, including SQL database. It allows blending of multiple data source in a single report. That's why I have chosen the Google Looker Studio. Now it's time to show the show the report. First, I will show the database connectivity, how I connected the report with Snowflake database. This is my connection. We need to connect the Snowflake database. We need the URL. This URL has put in here. I collected the URL from Snowflake database and choose the role and choose the data warehouse which I have created in Snowflake, and choose the as well as choose the database, choose the schema, and the query. I have created the view in Snowflake, and this is the SQL statement, and this is all about the connectivity. And this is the simple representation of this data. I don't want to I didn't want to go to very fast analysis of this data. Just simple, quite simple, some column. With this column, some chart I have built. This drop down, you can choose anything from here, and as well as the report has changed, data has changed in the visualization. And so I can take some insight from this data of YouTube trend analysis in Google Looker Studio. And this is the end of the Google Looker Studio presentation. Now this is time to wrap up our end-to-end ETL pipeline. We built a scalable workflow using Python, Airflow, Spark, and Docker to process data efficiently. We leverage S3 for storage, Snowflake for warehousing, and finally visualize insight in Google Looker Studio. This pipeline is not just a powerful but also modular, making it easy to scale and adapt to real world data needs. If you found this tutorial helpful, don't forget to like, subscribe, and leave a comment below. See you in the next one.